Early July in Texas's Hill Country, a region locals call Flash Flood Alley. The place was already set for disaster. Rugged limestone hills, dry soils that shed water instead of soaking it in, and river basins prone to sudden rises made it a flash flood hotspot. Between July 3rd and 4th, the remnants of Tropical Storm Barry parked over the area, dumping mind-boggling rain for months' worth in just a few hours. Some places saw 10 to 12 inches in that brief window. Tragically, that deluge caused the Guadalupe River to surge more than 20 feet in under 2 hours, sweeping away roads, campsites, homes, and sadly more than 100 lives, including many children. Now here's where the story gets twisted. A startup called Rainmaker, founded by Augustus D'Oreco and backed by Peter Thiel's Thiel Fellowship, had been using drones and planes to seed clouds. A real technique that sprays silver iodide to help clouds drop a bit more rain, often less than an inch per year. Rainmaker did carry out seeding flights in Texas, but they ended on July 2nd, and no flights took place on the 3rd or 4th. Then, noticing very high natural humidity, they voluntarily paused operations. Meteorologists and officials are unanimous. Cloud seeding cannot engineer the kind of massive, uncontrolled deluge that hit Texas. It only enhances rainfall in already existing clouds, not generates whole storms. Cloud seeding's been around since the 1940s. Scientists spray tiny particles like silver iodide into clouds. The goal? Help water droplets stick together, fall, and bring rain. Today, companies like Rainmaker use drones and radar to do this in places facing drought, like Utah, Colorado, and Texas. But can they really make it pour? And how do we know if it even works? How do scientists track cloud seeding? Compare a seeded cloud with one that wasn't. Scientists look for differences in rainfall, cloud lifespan, droplet size. They also use weather radar and satellites to watch cloud activity from space and track how much rain falls and where. Then come the ground sensors. These track how much rain fell, changes in temperature, humidity, and wind. Finally, it's all plugged into a computer model, which compares decades of weather data to see if seeded clouds actually gave us more rain than expected. So, does it actually work? Well, yes, but only a little. Most studies show cloud seeding might increase rainfall by just 1 to 5%. Enough to help crops or refill a reservoir, not enough to cause a flood? Wait. So what about the Texas flood? Some people online said artificial rain caused the deadly July 2025 floods in Texas. But here's what really happened. Cloud seeding stopped 2 days before the flood. A real storm system brought up to 12 inches of rain in hours. The region's natural geography turned it into a flash flood disaster zone. So, let's look at what the science says. First, cloud seeding needs clouds. No clouds, no seeding effect. It's not creating weather, just nudging existing clouds to rain a little more right then. Second, if it works at all, the rain happens within minutes to a few hours after seeding. There's no mechanism for the chemicals to float around for days and build a giant storm later. Third, a seeded cloud might rain an extra millimeter or two. Fourth, there's no delayed chain reaction. There's no known scientific pathway for seeding a cloud on the 2nd of July to trigger a storm system on the 4th of July. Massive storms are driven by ocean moisture, jet streams, atmospheric pressure systems, and heat buildup. Despite this, conspiracy theories spread online. Some blamed Rainmaker, Peter Thiel, even claims of weather weapons. Extremists targeted weather radar infrastructure, and CEO D'Oreco reportedly received hundreds of death threats. Political voices, including Senator Ted Cruz and meteorologists, flatly rejected the weather control theory. What can be done? Experts and engineers argue that more rain gauges, radar systems, alert sirens, and real-time flood modeling are crucial to saving lives in the future. Meteorologists said it was a natural, devastating flood, made worse by geography, climate change, and outdated warning systems, not cloud seeding. To prevent the next tragedy, we need science, infrastructure, and swift action.
Subscribe and hit the notification bell so you don't miss what's coming next. Share it, because some stories are meant to be discovered together. And stay curious. I'll see you in the next chapter.